Example 4. Recall that times required to pack the stereos can be described by a normal model with a mean of 9 minutes and a standard deviation of 1.5 minutes. The times for the boxing stage can also be modeled as normal with a mean of 6 minutes and a standard deviation of 1 minute. What is the probability that packing 2 consecutive systems takes over 20 minutes? So we are told a normal model applies, and it is reasonable to assume that the packaging time of one system with another are independent. So this will allow us to use normal model. We always have to check that condition. So we'll say I can use a normal model to estimate the packing time of 2 systems. Okay, now we're going to state what that normal model is. So we say n, and then we do expected value, standard deviation. So n9, 1.5. So now let's sketch the curve, see what we're really looking at. We'll end up with a mean of 18. And we want to find over 20 minutes. And so we want to say over, so we're shading to the right there. Okay, so where'd that 18 come from? Well, the expected value equals 2 times 9, which is 18 minutes. The standard deviation equals the square root of our variance squared. So 1.5 squared plus 1.5, which equals 12.12. So we had to square the standard deviation of 1.5, the standard deviation squared to the second system to get the variance, then square root those. You can never add standard deviations, only variances. So we had to find the variance first. Okay, now we're going to calculate our z-score. So we're going to do 20 minus our mean of 18 minutes over 2.12. This equals 0.94. But remember, this is the area to the left of 20. We went to the right, so we're going to have to do the complement. So the probability that our z-score is above 0.94 will be 1 minus 0.8264, which we get from the z-score table. That's the value, the percentage at the probability at z equals 0.94. And this comes out to be 0.1736. So, according to the normal model, there is a little more than a 17% chance that it will take longer than 20 minutes to package 2 systems. And it asks for the probability, and we've provided that 0.1736, and we explained it a little bit better with the percentage, which most people understand a little more clearly. Okay, what percentage of the stereo systems take longer to pack than to box? So we need to define a bunch of variables here. Let P equal the time to pack a system. Let B equal the time to box a system. And let D equal the difference in those times, the difference between packing and boxing times. And since we're doing packing first, it's assumed that it's packing minus boxing. So now we're going to state both of these models. Packing, normal model, 9.15. We already established the rules in the first problem, so we don't have to state those again. Boxing is a normal model with a mean of 6 and a standard deviation of 1. So we are told both random variables follow a normal model, and it is safe to assume packing and boxing times are independent. There's no reason to think the time it takes to pack a system has any effect on the boxing time. Okay, so the expected value of the difference equals the expected value of packing minus boxing. Which equals 9 minus 6, or 3 minutes. The variation of the difference equals the variation of packing plus the variance of boxing, which will equal 1.5 squared plus 1 squared, which comes out to be 3.25. To find the standard deviation, we do the square root of the variance of the difference, which will equal the square root of that 3.25. This is going to equal 1.8028 minutes. Okay, so this gives us a normal model of 3 and 1.8028. So we're going to sketch that out. 3 is our mean, and we want to have a difference of 0 or above because we want the packing time to be more. So we're shading everything above 0. So clearly this probability is going to be pretty big. 0 is a little bit before 2 standard deviations away, so we just kind of estimated that. And then shade in everything to the right of 0. So now let's calculate this out. Our z-score is going to be 0 minus 3 over the standard deviation of 1.8028. This is going to equal negative 1.664. So the probability that our z-score is greater than negative 1.66, again, we're doing greater than because we're shading to the right, will equal 1 minus 0.0485. So this equals 0.99515. So finally, we're going to end by saying, according to the normal model, about 95% of the time, it will take longer to pack a system than to box it.